Hello. Today we're going to talk about the slope-intercept form of a line. So you might have to excuse a little bit of background noise. I'm recording this in the mysterious science closet. What we're doing today, again, slope-intercept form. So we got a couple of definitions we're going to talk about first. So the first one is slope. I already filled it in because we've been talking about slope for a couple days now. Slope is just when you have a constant rate of change, right? It's talking about the steepness of a graph, right? So actually I have this graph down here that I'm going to use as an example in just a second. Right, so let's say that I also added this purple line to the graph, right? That line that I just added is much steeper than the red line that was there before, right? The purple line is also going up, right? So it would have a positive slope compared to the other red one going down, which would have a negative slope, right? So that's all we're talking about with slope. We also need to talk about x-intercepts and y-intercepts, right? So instead of writing out a definition, I figured that we'll use this picture here, right? So on your paper, if you don't already have this, it might not be a bad idea to kind of copy down what I've got. So if you need to pause, go ahead and do that. But when you got it, right, we're going to talk about x-intercepts, right? I've also got my axes labeled, right? The x-axis is this one that's going left and right. The y-axis is the one that goes up and down. Specifically, an x-intercept is when you are crossing that x-axis with your line, right? So that is our x-intercept. And by the same idea, the y-intercept is this one up here where we cross the y-axis, right? So a couple things that we're going to need, right? First off is going back to slope for just a second. The variable we use to talk about slope is m, right? So it's not a bad idea to put there just as a little reminder. We also have a variable that we use to talk about the y-intercept. That's b. Thankfully, the x-intercept doesn't have its own little special variable to go with it, and that's one less thing we have to remember, so that's kind of nice. But slope is m, the y-intercept is b. Right? On this front page, we've also got our slope formulas, right? So again, same ones that we've been working with for a little while now. If you need to pause a second to copy those down, go for it. That's same with any of this. If you ever need to pause, just do it. I won't even know, right? But we've got our two slope formulas, and we're going to use those a little bit as we're working through this lesson as well. But the slope-intercept form of a line, that's what we're really worried about today. So the slope-intercept form of a line looks something like this, right? It's y equals, and then I'm going to try and color code a little bit. It's mx plus b, right? And some of these we already talked about, right? So the m, right, we were just talking about, that's the variable that we use to represent slope. As for the b, that's the variable we use to represent the y-intercept, right? The x and the y, right? Whenever we have a problem where it's like, give me the slope-intercept equation that matches this information, like whatever, that's what we're going to leave them as, right? These are still going to be x and y in our answer. The slope and the y-intercept, however, are going to turn into some numbers, right? So you might have like y equals negative 3x plus 6, right? Who knows? Whatever the numbers are, right? But x and y will still be x and y. So one of the things we're going to want to be able to do with this slope-intercept form is rewrite other equations to be in slope-intercept form, right? Especially when we get to graphing these, it's going to be really important to be able to kind of manipulate them and make them a little bit easier to work with. So in this first problem here, right, what I'm going to do is I need to get that to look like y equals mx plus b. So let's take a look at what's different, right? If I'm looking at the two different sides of the equal sign, one part that's different is that this y has something hanging out with it, whereas it didn't in the mx plus b form. The other thing is that this side over here has stuff in parentheses, which this one didn't. Right? So those are the two things we're going to have to deal with, are the parentheses and then getting the y by itself. So just like any old equation, I'm going to split it down the middle. And to deal with the parentheses first, right, that's what I would recommend, is I'm going to take this 3 and I'm going to distribute it in there. Right? So I'm going to be multiplying that 3 into the parentheses. When I do 3 times x, I get 3x. When I do 3 times negative 9, I get negative 27. All right. So parentheses are gone. That's good. Next part we need to get the y by itself. So in order to get rid of that minus 5 that's hanging out next to it, I'm going to add 5 to both sides. All right. So when we do that, the 5's cancel out. We're going to get that y is equal to 3x minus 22. All right. Once we're there, that's actually it, right? We got y equals mx plus b, right? It's set up just exactly the same way. Something that's good to be able to do once you get it here, though, is also to be able to tell which one is the slope, which is always in front of the x, and which one is the y-intercept, which is the part that's hanging off at the end. Specifically on this one, something that is worth keeping an eye on is that the y-intercept is actually negative 22, right? We need that entire thing there, right? Not just 22, negative 22, right? But that's really all we're doing is we're multiplying, moving stuff away from the y's, and then that's our answer, right? So what I would recommend is try pausing here, trying this one out, and then unpause or keep on going as you need to, and then we'll see if we match up, right? So I'm going to start doing this one out. I'm going to multiply this negative 1/2 into the parentheses. We're going to have y plus 2 equals negative 1/2 x, and then negative 1/2 times positive 8 is negative 4. Right? So the parentheses are gone. Now I need to get rid of the 2, so I'm going to subtract 2. Right? I'm doing the opposite thing to cancel that out next to the y. So y is going to be equal to negative 1/2 x minus 6. Right? And again, not ever a bad thing to be able to pick these out. Negative 1/2 is our slope, and negative 6 is our y-intercept. Right? So that's one of the things we want to be able to do is take care of situations like that where I just need to get the y by itself. Right? So if we flip on to the second page here, right, this wants the equation of a line in slope-intercept form that goes through these 2 points that they're giving us. Right? And I'm going to be honest right off the bat, these ones can be tricky, right? There's a lot of stuff going on with them. We're going to take it one piece at a time. So one of the first things I'm going to do is if I want something in slope-intercept form, I'm going to need to find the slope, and then I'm also going to need to find the intercept, because they don't give me either one. So to find the slope, right, that's going to be my first step. Right? What I'm going to do is I'm going to use our trusty slope formula. So I've got these 2 points, and if you like labeling them like I do, go for it. We got an x1, y1, and an x2, y2. And what we're going to do is we're going to plug them into our slope formula that we had on the front side. Right? So that's that y2 minus y1 over x2 minus x1. So first up is the y2, which we labeled was 8, minus the y1, which was negative 2. On the bottom, we've got the x2, which is 3, minus the x1, which is 1. Right? So as I'm looking at this slope formula that we've got all set up and ready to go, I notice on the top that I've got that minus situation we've mentioned in class a couple times. If you are ever trying to subtract a negative number, like 8 minus negative 2, then you just treat that as one big plus sign. Right? So 8 plus 2 is 10, and 3 minus 1 is 2. Right? After we get there, 10 divided by 2 is just 5. Right? And like I've mentioned a couple times in class as well, if the answer comes out nice and clean like 5, use 5, right? Don't leave it as 10 over 2. If it doesn't come out nicely, say you ended up with like 1/3, leave it as 1/3, right? It's actually going to be a little easier than dealing with 0.333, all that. Right? But long story short is we found the slope, so we're partway there. The other piece we need is we need to find the y-intercept, right? So that's going to be our second step. So find the y-intercept. So when we're doing these types of problems, right, we're trying to get ourselves to a y equals mx plus b sort of situation, right? So let's think about what pieces of that we already know. Right? We just figured out that the m is 5. So what I'm actually going to do, I'm just going to replace that with the 5. We don't know what the b is, so I know that like this b over here is going to stay b because I don't know what number to fill in yet. But the x and the y, right? I know a little bit ago I was telling you that as our final answer, we're going to leave it as x and y, but we're not at our final answer yet, right? So what we're actually going to do is we have some x's and y's that we can use from this problem, right? Specifically these ones we used for slope, right? So you can take a point and grab the x and the y from it and plug those into the formula, right? That'll help us figure out what b is, right? So in my case, I'm going to choose to use this point because they're both positive numbers, and that sounds pretty nice to me, right? I'm going to take the x, which is 3, and I'm going to plug it in where the x was. I'm then also going to take the 8, which was the y, and plug it in where the y was, right? So when I do that, it's now going to look something like this. 8 equals, oops, trying to keep the color coding going, 5 times that 3 there, plus b, all right? So after we get there, right, now we've plugged in every piece of information that we could know. We just don't know what b is. So from here, all you gotta do is just solve it out. All right, so 5 times 3 is 15. All right, now we need to get rid of that 15, so I'm going to subtract that from both sides. 8 minus 15 is negative 7. And the only thing left over there is b. All right, so we just figured out what our y-intercept is. Right, so we used our slope, we used one of the points, we plugged it all in, and then we solved for whatever b is. Cool, so then we got one step left to go, and honestly this is the easiest one. We need to plug in the m for the slope, and we also need to plug in the b for the y-intercept. Right? So this is where our final answer is coming in, right? So this is where y is going to stay a y. The m is whatever we found out, which was 5. The x is going to stay an x. And then that b is tacked on to the end, so minus 7. Right? So that's what we're trying to get to, right? We're trying to get to this final answer where y is equal to 5x minus 7. Right? Slope of 5, y-intercept of negative 7, good to go. Right? So there is another one of these under here. What I would recommend is, try pausing, give it a go, and then unpause when you think you got it, and I'm also going to do it out real quick. So I am going to go a little tiny bit faster than the first one, right? Just in the sake of not having this video be 45 minutes long. So we've got an x1, y1, and an x2, y2. I'm going to find my slope to start us off, right? So to find my slope, I'm going to be saying, all right, y2 minus y1 and x2 minus x1. So we got that minus minus situation going on the bottom. That's why I turned that into a plus sign. So we're going to have negative 5 over 10. That's actually the same fraction as having negative 1 over 2, negative 1 half. Right? So that's what I'm going to use here because honestly, that sounds a lot nicer to work with than negative 5 halves. All right, good enough. After that, I need to solve and figure out what my y-intercept is. Right, that is my second step. So again, what I'm going to be doing is I'm taking one of the points, and I'm going to choose this one because the numbers are smaller and there's no negatives. Right, I'm going to take that point and I'm going to plug the y in for the y, so 1. I'm going to plug the m in for the slope. I'm going to plug the x part of that point in for the x, and then this b is the part that I don't know. So as I go through this, right, negative 1 half times 2 is just negative 1. And then to get rid of that, I'm going to plus 1 to move it over to the other side. Right? So what we're going to find is that 2 is equal to b. Right? So that is our y-intercept. Right? So again, I know I just blazed right through that. Right? If you need to take another quick watch through and follow along, maybe at like half speed or something, that's okay. But again, I don't want you to have to listen to me for who knows how long, maybe like a full hour, gosh. All right, so our last step is we need to plug them in. All right? So when I'm trying to get y equals mx plus b, y equals m, which was negative 1 half, mx, and then plus b at the end, which in this case is plus 2. All right? So, again, not the easiest of problems, right? Lots of stuff going on. You've got to find your slope, find your y-intercept, plug it all back in. That's quite a bit to do for one problem. So if they seem a little tough at first, that's okay. They're going to be tough because we just started doing them, right? So don't be too hard on yourself if it's not making complete sense. We'll get better at them as we go. So one of the other things we're going to do is try to write the equation in from a graph, right? So we still want this y equals mx plus b, right? I need a slope and a y-intercept, but I want to use the graph now. So when we're using a graph, right, most of the time, it's going to also give us what the y-intercept is already. So if I'm looking on this graph, the y-intercept is where it crosses the y-axis right down there, right? So that purple dot tells me that my y-intercept is at negative 4. Cool, we're already partway done. The other thing that we want to do with this is we need to calculate the slope. So this is where they can get a little bit tricky. So depending on how the printer decided to print things out, right, you might not be able to see all of these extra little grid lines. Like I'm seeing all of these grid lines on here, right? You may not be able to see those on your paper depending on how it printed. However, something to be mindful of is that the scale on this graph is a little bit different, right? So we can see that there's 0 in the middle, and then this would be where 1 is. Then we got 2, and then 3 and 4, right? Topping out at 5. So on this graph, right, things are a little bit stretched out, right? The scale is not quite what we would expect it to be, right? So don't just count the boxes blindly, right? That is not 4 steps. That is supposed to just be 2 steps. But anyway, so we've got these 2 points over here that we could even use. If I wanted to figure out the slope, remember that we can figure it out as rise and run, right? So if I'm trying to figure out the rise and run between those 2 points, right, let's take a look. To go from this first point that I just put the laser pointer on, right, I'm going to be going up 2, right? So my rise is 2. After we go up 2, and I guess I should do it this way, right? After we go up 2, we went over 1 in a positive direction, right? So our slope is 2 over 1, which is the same thing as 2, right? Last but not least, we just got to throw it all together, right? Y equals m, the slope, x, and then plus b, which was that y-intercept we found right at the start, right? So there's our equation, 2x minus 4, right? Hopefully these ones don't seem all that bad, right? Again, what I would recommend is try pausing on this one, see if you can figure out your y-intercept and your slope, and then unpause and see if it matches up with what I'm getting. All right, so hopefully you gave it a go. All right, so again, they're giving us the y-intercept here. My y-intercept, oops, sorry, not y, b equals 2. As for the slope, it's doing the same thing, right? The scale is a little bit off, so every 2 boxes, at least on my screen, like, again, your paper might show it a little differently, but every box on my screen is a half, right? So if I'm trying to figure out the rise and run from one of these points to the other, I got to be a little bit careful as I do it. All right, so to go from that purple point to the other one, what I'm going to need to do is I'm going to need to go down, and because I'm going down, it's a negative 1. After that, I'm going over, and from the looks of it in my eyes, right, it looks like we're going over 4. Since I'm going to the right, it is a positive 4. All right, so if I'm thinking about rise over run, my rise was negative 1, my run was 4, and that's my slope. Last but not least, don't forget to do this, right? It's the easy part at the end. Y equals m with an x next to it, and then plus that b just tacked on to the end. All right, so negative 1/4 x plus 2. All right. So hopefully that seems all right. Like nothing super duper fancy. I will say another way that you could do this one, and you don't need to erase everything on your paper, right? But I'm just gonna do this as an example real quick. Another way you could approach this one is you could grab the coordinates of these points, right? 0, 2, and 4, 1. If you go about it that way, then all you would do is the same process as what we did on examples 3 and 4, right? You would find the slope, find the y-intercept, plug them in, right? That's if you wanted to do it that way from just the 2 coordinates. What I find is that doing it this way is a lot easier, a lot faster, right? Requires a lot less, like, process than the other way. Right? So the other thing we got to talk about is how to graph these, right? So if you need to pause this for a second, or either right now or at the end of this, right, we got a couple of things we're going to fill in here. So the first step when we're trying to graph these types of equations is we need to plot the y-intercept, right? And again, remember that that's the b, right? So you're going to plot that on your y-axis, either up and or down, right? After that, we're going to need to use the slope, and we're going to do that rise over run thing to get a second point for ourselves, right? So after we do that, we will now have 2 points on our graph, and then it's everybody's favorite time, connect the dots, right? We're going to graph the line after that, right? And we'll talk about that when we get there. There's a couple little extra things that I want you to make sure you do when you graph the line, right? So on here, we've got 4 different equations, right? So if you happen to have extra colors or a ruler, those might be helpful here. If not, that's fine. We're going to do our best with it. It's not the end of the world if it's not perfect. So I'm going to start out with this one, and I'm going to do that one in red. So y equals 2x plus 5. Right, so first off, I'm looking at the equation, and I'm saying, like, all right, what's my y-intercept, right? I know that that's the piece that's way on the end, so that's 5. So I'm going to do is I'm looking at my y-axis here. I know that that 5 is where I'm crossing the x-axis, or sorry, the y-axis. So that's where I'm going to put my first dot. Right. After that, I need to worry about the slope. Right. My slope is 2. And we were talking about doing rise over run. But how does that work if there's only one number? Right. So what we have to do in this case is we have to turn 2 into a fraction so we can actually have a rise and a run. So 2 as a fraction is the same thing as 2 over 1. Right? So it's telling me from that starting point, from that red dot there, I'm going to go up 2 spaces and then over 1 to the right to get that second red dot, right? And that's where I'm going to start where my line is going. What I find sometimes is that, especially if I'm trying to do these kind of freehand, I'll then go up 2 and over 1 again from that dot just to get a third point to line it all up with, right? But once you get it, right, then what I want you to do is try your best, and I am going to cheat a little bit because I have the computer at my disposal, right, is we're going to not just connect the dots, we're going to go all the way through the graph, right? The reason why is because you got all this graph, you might as well use it, right? Some of the stuff we're also going to be doing in the future is going to need us to be able to see, like, what is this line doing when it's way over here, right? If all I did was I just graphed a teeny tiny bit of it up in this spot, I wouldn't have any idea exactly where this would be, right? So use the entire graph, right? Go all the way through, right? So let's take a look at the next one over, right? So on this one, y equals negative 4x plus 7, same deal. I've got my b, which is at 7. So on my graph, my y-intercept of 7, 10, 9, 8, 7, it's right about there. That first blue dot is. After that, my slope is negative 4. And again, I want to think about that as a fraction, so I'm going to say it's negative 4 over 1. Right? So what that means is from that first blue dot, I'm going to go down 1, 2, 3, 4, and over 1 to the right, because that 1 is positive. Get that second dot there. And again, what I like to do is then keep going 1, 2, 3, 4 down, 1 over, right? Just like use the slope again to get another dot, just so it's a little easier to line up, right? Once you get that, oop, mine's a little bit off. So again, I'm going to cheat a little bit. I know that you can't do that on yours, but that's okay, right? But again, we're going to use up the whole graph, and hopefully our line looks something like that, right? So then we've got a couple that look scary, right? Because they've got fractions. These ones are actually sometimes easier, right? So just like before, we've got the b, we've got the m, right? Something to be mindful of on this one is that the b is actually negative 4, right? So don't just plot it up at 4. We need to start down at negative 4 on that y-axis for this one, all right? After that, my slope is 2/3. So that's telling me that I need to, from that point, from the purple point, go up 2 and then over 3. So when I do that, that's going to land me right where that second purple dot is. Right? And again, I like to, do it one more time. So up 2 more, over 3 more, get that dot there. You could theoretically, you could keep on going, right? I could put one over here. I could go down 2 and backwards 3, right? I can kind of like sketch out the entire line that I'm going to want here if I wanted to. You do not have to do that, right? All you really need is just 2. I like to do 3 because it makes it a tiny bit easier without too much extra work. All right, so then after that, again, we're going to connect them up and we're going to use the entire graph that we have at our disposal. Right. So what I might suggest is if you haven't paused to try one out yet, which I know I didn't say anything about, try out this last one that I'm putting in the green here. All right. Try and graph that one on there. You've got your m, which is negative 4/5, and you've got your b, which is negative 1. Right. So hopefully you gave that a shot. If not, try it out. It's not going to hurt you. Right. But what I'm going to do is I'm going to put my y-intercept down at negative 1, and then my slope is telling me to go down 4 and over 5. Right. So this can be a little tricky. If I have a fraction, like negative 4/5, kind of set up like it is in the problem, that means the exact same thing as negative 4 over positive 5, right? And this is what I would recommend thinking about that as, because it makes our slope a little bit easier to work with. So that's telling me down 4, and then the 5 is positive. So 1, 2, 3, 4, 5 that away. Right? Again, I like to do one extra just to line it up a little better. Right? But then once we get that, we go ahead and we run that line all the way through the graph, just like that. Right? So, hopefully it doesn't seem that bad, right? Like, I know that we just did 4 all at once, right? And like our graph looks a little bit like a mess, right? But I'm hoping that as we went through it, each individual one seems all right, right? So something that's worth mentioning as well is that, if we ever need to put multiple lines on the same graph and you only have one color at your disposal, like say all I had was blue, what I might suggest is to number them, right? Like this is line number 1, and then at the edge of it, put a little number 1. This is line number 2, put a 2, right? So if that's something that you're kind of struggling with on your paper, is like, oh my God, there's so many lines, I can't tell which one's which anymore, right? Use a little number system, right? Just to help you keep track of like, oh, this is how I did this one, right? So last part that we're going to talk about on here, and then I promise I will stop talking, is that I would like you guys to pause here and try graphing all 4 of these, right? So pause it here, give it a go. I'm then going to do them out right afterwards, right? But give it a shot on your own first. All right, so I'm going to do these ones out, and again, just like some of the other examples, I'm going to speed through it a little bit more than before, just to make sure that you don't have to listen to me for forever. I guess that's just going to be a trapezoid. That's fine. All right, so we've got our M and our B. I'm going to put that 5 over 1 just so that I have a slope to work with as well. All right, so we went up 1 for our y-intercept, and then up 5 and over 1 for our slope. Right? So on this one, that's going to make us look something like this, give or take. Ooh, look at that. It's lined up pretty nice once it snapped straight. All right, so that one's done. All right, let's try out this one. All right, so again, we've got M, and it's over 1. And we've got B over there. So I've got up at 6. I'm going down 3 over 1 to get another point. And I'm going to do it one more time just to make sure that I can really line myself up well. And then our line's going to look something sort of like this. Look at that. Not too bad. All right. Again, if you are having trouble keeping track of which line is which, just do a quick little numbering system. All right. For mine, let's keep on going. All right. So if I've got something like this one, right? -3/7 is our slope. -8 is our y-intercept. So I'm going to start down at -8. And then I'm going to have to go up 3 and over 1, 2, 3, 4, 5, 6, 7. All right. You might notice I also did this on the one in red, is that I don't have room to put a second point down. Right? But thankfully these ones are already far enough apart that it's not that bad that I can't like line it up with a third dot. Right? So run it through both of those. Boom shakalaka, there we go. Right? There is line 3. Right? And then last but not least, right? Line number 4. It's got a slope of -2/5, a y-intercept of -3. And again, if you haven't actually been pausing and trying these out, try this last one out. It's going to be okay, even if you get it wrong. All right, for this one, I'm starting down at -3 for my y-intercept. And then I'm going down 2 and over 1, 2, 3, 4, 5 to get my second dot. On this one, I do have space, so I'm going to go down 2 and over 5 again, just to make it a little easier to line up. All right. So, once we get that, again, I'm just going to keep myself organized, label it, just so I can remember which one's which, especially if I'm only working in one color. And then that's really it. So I will say that there are some word problems at the end of these notes that you have in front of you. We are going to skip over them, at least for now. We might come back to them sometime during class, right? But at least for now, that's the end of this. So be sure to check back on Google Classroom for any other directions and whatnot. And I will see you later.